I just wanted to thank you for coming out here tonight. It's just amazingly impressive to see so many people here in the room to talk about native fish recovery and carp. So it's really clear that as a community you care a lot about your rivers, which is fantastic. And as Shuan mentioned, I'm here to talk. I would like to talk to you tonight not just about the virus. I'd like to talk to you about a range of measures that have been employed in Australia to try and control carp over the last few decades and the sort of results that have been received. But before I go any further, I really just want you guys to each think about the last time you saw the rivers in your region look like this. So clear water, abundant aquatic vegetation, all the bugs that live in that vegetation, and of course all the fish that eat those bugs. Because in the last 15 years or so that I've been working in fisheries research and management, much of it in the Murray-Darling Basin, most of the sites that I've been involved in surveying look kind of more like this. Muddy water, much less common aquatic vegetation, and of course the bugs and the fish are much less common as a result. Now I put this photo up here tonight because it actually reminds me of a particularly important period in a moment in my life when I was about 5 or 6 years old, which incidentally was about the time when I decided what I wanted to do when I grew up, which is work with fish. And I actually came to that conclusion whilst I was on a fishing trip with my dad. And of course the reason I loved fish is because I loved to fish. And up until this point, I'd been living in Tasmania, mostly chasing trout, so clear mountain streams and all that sort of thing. We moved to the mainland, and all I wanted to do was catch a cod. I'd seen these amazing, huge fish, and I just wanted to catch one. And so my dad took me to the Murray River. And I've got this indelible impression in my mind of this particular day when I was sitting on the bank of the Murray River, looking at this enormous river, bigger than I'd ever fished before, and thinking, why is this river so muddy? And they haven't even had a flood here recently, and I reconciled on that day that maybe all of the big rivers in Australia were naturally muddy for a reason that I didn't really understand. And the second memory that I have from that day happened later that day, much later in the afternoon, when my rod buckled and my reel started screaming. And I picked up the rod and felt this big tail beat against the line, and I was just frothing. And I remember shouting, "It's a cod, I've got a cod!" My parents came running out of the campsite and came down, and I fought this fish to the bank, and it eventually broke on the surface of the water, the muddy water, and flashed golden. And I remember feeling this disgust in my stomach. It was a carp, not a cod. And I remember feeling this disgust in my stomach, and I reflect on that moment several times since, because I felt that disgust for this fish before I probably even knew what a carp was. I really don't know where I got the understanding that this wasn't a really good animal to have in our system. But I share those two memories with you for a couple of reasons. Of course, our big rivers aren't naturally turbid. They're not naturally muddy. If you speak to your grandparents or even some of the older people in this room will remember our big rivers used to run clear, and you could see carp in cod in 10-foot deep water sitting on a snag, and we could have that memory again, but we do have to take action on carp. And of course, if we do that, maybe it'll be a bit more easy to catch a cod, although I haven't had that much success as the years went on. So look, a bit of context first about carp, although we've had some really good context already that sort of highlights that they are a really important pest species globally. But in Australia, there was a study that was done about a decade ago that really highlighted that the Australian community rank carp among the 4 most significant and disliked vertebrate pest species in Australia. And that's a really important point. So what that tells me is that feeling of disgust I had on that day was shared by most of my fellow Australians, which makes me feel pretty comfortable. But it gives us the ability to consider some pretty courageous management approaches for this pest species, because Australians want us to take action on carp, and that's good. Why do they want us to take action on carp? Well, it's because, as we've heard, they're ecosystem engineers. What that means is that carp in our systems, in our ecosystems, will shape the ecosystems in ways that advantage them and happen to disadvantage our native fish. And primarily, as you've heard, it's by the way they feed. They grab a big mouthful of mud, they eat the greeblies in the mud, and they spit the mud back out. If you've got hundreds of thousands of carp doing that all at once, you end up with a muddy river, just like I showed you the photo of. And of course, that affects on the water plants, and it affects the bugs, it affects the fish. And the impacts of carp in our system aren't just ecological, they're social and they're economic. There's been a few estimates, attempts to estimate the economic cost of having carp in our waterways, and that the highest of those was at up to $500 million a year. That's a lot of money to just sit there and do nothing and let carp continue to proliferate. So when you line all that information up, what it shows you is the Australian community want action taken on carp. It costs us a lot every year to have carp in our system, and so it's really not acceptable for us to do nothing. We must do something. And today I'll be telling you a little bit about what has been done. Of course, and the last point I wanted to make is part of the reason why it's economically so expensive to have carp in our system is just because there's so many of them. They make up more than 80% of the biomass in our river systems, as we've heard, up to 93% in some places. That's just astronomical. It's no wonder it's hard to catch a cod. Okay, so control actions. Over the last few decades, there have been a range of approaches that have been employed to try and control carp in our systems. Every time we finish surveying a river and we go to a restaurant or go to the pub, people come up to us and they ask a couple of questions. Universally, they ask, what are you doing about carp? And the second question is, are you winning? So I want to share with you some of the insights about, well, answering those questions. We've heard a bit about carp cages tonight. I won't go into too much detail about how they work. I'll just really point out, Clayton is exactly right. It's a beautiful, elegant Aussie innovation. And look, they do successfully segregate native fish from carp because carp do jump and native fish don't, and that's great. And in some places, I was exactly right. They do work, and they can remove, tons of fish from the river, which is great. But in other places, they're fairly ineffective. They can, in some places where they're installed, they can remove about 1.5 carp per day, which is not a lot. And when you consider that the biomass of carp, like I said before, it's 80% of the fish biomass, we're talking hundreds of thousands of tonnes, possibly millions of tonnes in the Murray-Darling Basin. So could we rely on this as the sole way of controlling carp and reducing the impacts of carp in the basin? Probably not. Part of the solution, but not the solution by itself. Commercial fishing. Commercial fishing is actually the most effective tool that we have had available to us to date to control carp, and that's because our commercial fishers are extremely good at doing their job. They can find and catch carp, don't you worry about that. But there are a couple of reasons that will limit our ability to rely on commercial fishing as the sole way of reducing carp and reducing their impacts in the Murray-Darling Basin and indeed all of Australia. Number one, I was having a chat to some of the commercial fishers here tonight. I'd like to thank you guys for taking the time to come such a long distance to join us here tonight. That if more than 2 tonnes, I think a week, was mentioned, of carp arrive on the Sydney Fish Market floor for sale, it affects the price. So essentially they get less money for the carp if they land more than 2 tonne per week. And so there will come a point where it's not economically viable to catch larger and larger and larger volumes of carp. And remember, we're talking about a heck of a lot of carp. The second issue, of course, is that if you waved a magic wand and the market didn't pay less money as you put more carp on the floor, so they could catch as much as they possibly wanted. As you take more and more carp out of the system, there's less carp to be caught, so you spend more to find them, and so there will come a point where it's commercially not viable to catch that last fish. So commercial fishing is absolutely part of the integrated solution to controlling carp in Australia, but can we rely on it as the sole way of reducing impacts? Possibly not. Another behavioural difference between carp and our native fish, which is fantastic, is that as the water levels in a wetland start to drop, carp start to move deeper into the wetland, and our native fish pick up on the cue of the dropping water level and leave the wetland. So you can actually modify the water level in a wetland deliberately to strand carp. We know they love to spawn in wetlands, so we can modify the water level to separate them from their spawning habitat, but we can also deliberately strand them, as you can see here. Another fantastic tool, but are we going to remove hundreds and thousands of tonnes of carp from the Murray-Darling Basin using this measure? Probably not. This little guy here is a Judas carp. You probably can't see this, but this is a radio transmitter that's sticking out of his belly there. So what you can actually do is you can put a radio transmitter, as Ivor's done many times before, and release it back into the water, and that fish will will swim back to its school, where you can actually then use seine netting or whatever measure you want to use to actually target the entire school, which is fantastic. It's a really effective way of controlling carp in a place like Lake Sorell in Tasmania, where they're trying to mop up the last remaining small number of carp in a system. But will be useful in controlling hundreds of thousands of tonnes of carp. Not right now. Maybe down the line, once we get to a point where we've really hammered carp numbers, it'll come in handy, but not right now. We can actually synthesise sex pheromones of carp. So this is female carp actually give off a chemical that attracts males to them when they're in spawning condition. And you can use those pheromones and put them in traps to increase the effectiveness of traps. This is fantastic, sexy science at its best. But I think, again, and it's been used in Tasmania with some success, but again, one of a range of tools in our arsenal, but probably not the solution in itself. Certainly it hasn't been to date. And community carp fishing events. So we've got carp bust events going on all over the Murray-Darling Basin, which is just fantastic. People come down in their droves, bring their kids, and they go down and they catch a whole bunch of carp, and it's a great day for everyone. But the data shows us that these events will remove 0.02% of the population of carp. So ecologically insignificant in terms of trying to reduce the carp impacts, but what a fantastic way to engage with the community and get them to help out with the solution. So it is part of the solution, but probably we need something more effective. And of course, this isn't a carp at all, this is a zebrafish. But this little species has been helping researchers at CSIRO to explore genetic technology. So you might have all heard about daughterless carp. If you haven't, I'll explain to you what it means. Essentially, you can create genetically modified carp that will only give birth to male offspring. Well, that's the theory. And they've been working on it for about 10 years to try and make this work. And having some success, but the reality of it is it's been very, very expensive. It's taken a long time. There's still a long journey to go in terms of cracking that piece of technology. And the thing about genetically modified carp is, let's say they cracked it today. We just picked up the newspaper and found out, hey, they've done it. That's great. What you then need to do is breed up hundreds and hundreds and hundreds of thousands of genetically modified carp, release them into the waterway so that they can actually have an effect of altering the sex ratio, so how many males and how many females are in the population. So you have to stock so many genetically modified fish in there to get a result. And of course, carp live for, as we've heard, nearly 40 years, and so it will take several generations to have a result. We're talking more than 100 years before we fix this problem. We've heard the Australian community want action to be taken on carp, and so we need to do something sooner than that. Okay, so they're the range of measures that have been employed in Australia over the last 20, 30 years or so. How have we been going? Well, I would say if I was a teacher giving us a report card, we'd probably get an E, maybe an F. We're not doing very well. The reason why is the Sustainable Rivers Audit data is showing us that over the last 10 years, despite all those measures, despite millions of dollars of investment, carp populations in the Murray-Darling Basin have increased fourfold. So whilst we've been doing all these things, they haven't just held pace, they've been doing really well. So I guess what I'm trying to say here is what we've been doing hasn't been working, we need to do something different. And so I'd like to talk to you about what that might be. Of course, I'm talking about the carp virus. So the CSIRO have been doing some research over the last 8 years, funded through the Invasive Animals Cooperative Research Centre, who fund my project as well. And they've found the research is really, it's just coming to its completion, and I can sum it up and say the research is showing that this virus has extremely exciting potential as a biological control agent for carp. This virus was first described in the late 1990s from the United Kingdom and also popped up in Israel. It's now found in over 33 countries around the world. This virus is extremely effective in killing carp. It will kill 70 to 100% of a naive population of carp. That just means a population that's never seen this virus before. So it'll kill 70 to 100% of a naive population in a very short space of time. The work by CSIRO has also tested carp present in Australia to find out if they're vulnerable, and he's found, Ken McColl and his colleagues have found that they are extremely susceptible to this virus in very, very low concentrations. That's a really good sign. And perhaps most importantly, his research has shown that this virus only affects common carp. Now I'm going to take you through some of the science here and share with you what I know from the work that's been done, not just by Ken McColl, but by others around the world. Before I go into answering the question that we get asked, we get asked two questions every time we talk to the community, and I've got to say I'm really looking forward to the opportunity to have more meetings like this where we get to speak to more people and listen to the issues and the questions they might have. The number one thing people ask generally is, how can you be sure that this won't be another cane toad? Now that's a really fair question, and I suppose the response would be the science that we apply to explore the potential of an organism as a biological control agent has become incredibly more sophisticated since the 1930s, and we have actually learned probably the most from that example of what not to do. And so that's a really unfortunate step in biological control science, but it's been an important learning process. The second question we get asked, of course, is how can you be sure that this virus is going to be safe for other species? And that's been the focus of most of the research over the last 8 years. And what we know by looking at viruses, other viruses that can jump from their host species to another species, is that the most important thing is how related the species is to the host species. So viruses will only jump from the host species to a closely related species. So we are very fortunate in Australia because we have no native cyprinids, which is the taxonomic group that carp belong to. There are no native species that belong to that group. No closely related species. The second really important component, of course, is for a species to be vulnerable to a virus jumping from the host species to that species, it needs to co-occur with the host species, and it needs to co-occur with the virus. That sort of makes sense. It has to come into contact with the virus if it's going to be at risk. So what that did was help us to shape our understanding of how we go about the process of researching this. So we knew we needed to look at closely related species that co-occur with carp, so they occur in the same places where carp occur. Now this is a pretty messy diagram. You don't need to understand be able to read all these names, but I'm going to take you through what this means. This is every order, so orders are just a taxonomic grouping of fish. So this is every order of fish that occur in Australia. Now, orders of fish that are branching really close to this right-hand side here are reasonably closely related. And of course, these ones that branch right over to the left here are very, very distantly related. Now, the thing I want to point out here, so this is cypriniforms. This is the order of fish that carp belong to, and of course goldfish as well. Now, as you can see here, there's 4 orders that are reasonably closely related, and you actually can't see the colour changes here, which is a shame, but what I want to point out is this one here and this one here, there are no representative species that co-occur with carp in Australia. This one here, siluriforms, this is catfish. Of course, we have catfish that co-occur with carp. So what that tells us is that we need to, at the most important thing, we need to test catfish and make sure that they won't develop this disease. And you can infer that if catfish species won't develop the disease, then much more distantly related species definitely won't develop the disease. Humans would absolutely not develop the disease caused by this virus. But rather than just focus on catfish species, CSIRO actually looked at example species from every order of fish that occur in freshwater and estuarine habitats in Australia, with the exception of 2. And the reason they didn't look at those 2 was because there were no species from those orders that occur where carp occur. So you can see here they tested golden perch, silver perch, Murray cod, olive perchlet, carp gudgeon, the ones that we mentioned before, rainbow fish, sea mullet, trout. Even though they're not native to Australia, they're economically important, so they tested them as well. Australian smelt, galaxids, 2 species of catfish, because as I mentioned, catfish are a pretty important group of fish for us to be sure to be safe, bony brim and eels, and lampreys actually. Now, the message I want to give you is there was absolutely no evidence of this virus replicating in any of the fish species tested, with the exception of common carp. Now, I use that term, that there was no evidence of replication of this virus. I use that pretty specifically because when you look at the way a virus affects a cell, what it does is it essentially unlocks the cell, climbs inside, and uses the mechanisms of the cell to create versions of itself, to replicate. So if there is no evidence of replication, it means that the virus is just doing nothing. It's inert, just sitting there. It won't interact with that species. And so that's really important. In addition to those fish species, they tested an example mammal species. They tested 2 example reptile species, 2 example amphibian species. They tested a crustacea, and they tested a bird species. So you can see what they're trying to do here. CSIRO were trying to look at groups of species that might interact with the virus by either a bird eating a fish, or speaking to your point earlier, sir, in relation to what happens if another species eats a carp. Well, they were looking at those sort of interactions in trying to test for these species, and the take-home message is there was no evidence of this virus replicating in any of these species that were tested. So in order to answer the question, is this virus safe for other species, with all of the information that we have available to us, we can say yes. Now, there's another reason that I want to share with you as to why we believe that this is a safe virus for other species, and that's because there are 2 different types of viruses. There are DNA viruses and there are RNA viruses. Now, They're basically called that because of the genetic material that they're based on. Now, RNA viruses are quite less stable. They will mutate more easily. So examples of RNA viruses are the human influenza virus, the Ebola virus, the SARS virus, H1N1, you know, all the ones you hear about in the media that are big and scary. They are RNA viruses, and that's because they can mutate really easily. DNA viruses, by comparison, which the Carp virus is, are much, much more stable. And as their molecules are bigger, so for viruses that have bigger molecules, they're even more stable again. The cyprinid herpes virus is the largest DNA virus molecule that's been described. So it's very stable. And an example, there's some evidence that supports that, is the fact that there are only 9 strains of this virus in all of the world, and they are 98% identical. So very low level of mutation. And of course, all of the non-target species testing, which I took you through a bit earlier, not just in Australia, but in all of the world, has shown no evidence of this virus replicating in those species. The other really important question we get asked, and one that I wanted to touch on tonight, is this virus safe for humans? From the information we have available to us, the answer is yes. There are multiple lines of evidence that support this that I want to take you through right now. Number one, there are no examples of any fish virus anywhere in the world ever causing disease in humans. That's a really nice first step. But there's some additional information that we can draw on. It's surprising for some people to realise that common carp, the same fish we have swimming around in our rivers, is actually one of the most aquacultured and consumed fish species in all of the world. There are farms all over the world, and they produce hundreds of thousands of tonnes of carp every year. And actually, this is a farm in Israel, and this is an outbreak that they had in the early 90s in that farm. So as you can see here, when they have an outbreak of this virus, basically guys jump in the water in their boxer shorts and just grab armfuls of the fish and chuck it in a net and take it to the tip. They've been doing that way ever since the virus was first described, and there's never been so much as an itch or a scratch or any sort of a health issue reported in humans ever since, despite the fact that they interact so closely with this virus on a daily basis. In addition to that, in Israel, they have a live attenuated vaccine that they give to their fish to protect them from this virus. A vaccine is just a weakened version of the virus. So what that means is there are literally hundreds of thousands of carp that are affected with this virus being eaten by humans all around the world today. And there's never been an issue that's been reported in relation to that. A third point as well that I wanted to mention, we went to Indonesia where they produce a lot of carp for human consumption. And in Serata Reservoir, where most of their carp are grown, as soon as the carp start to show clinical signs of this virus, the first thing they do is kill them and send them to market. So people are actually eating the wild-type virus that we're looking to use in Australia every day. And there's never been an issue reported in terms of human health. And of course, as I mentioned earlier, they tested lab mice to see if they developed the disease that's caused by this virus, and of course they don't. Okay, so now I want to talk a little bit about the process. It is extremely difficult to consider importing a notifiable disease into Australia to release into a natural water body to control a pest species. It should be really difficult. We need to seek approval under 4 key pieces of legislation. Each of those approval processes are hundreds of pages where we need to take all of the data and synthesise it and build a case around why this is safe and why the virus is effective and how we can be sure that it will be safe for humans and safe for ecosystems. So, as I mentioned, we need to get approval under 4 pieces of legislation. Where are we at in that process? Well, we've applied under the Quarantine Act to be able to bring the virus into Australia. We've applied under the Biological Control Act to be able to register this virus as a biological control agent. We will be applying under something called the Australian Pesticides and Veterinary Medicine Authority Code to have the virus registered as safe for use and effective in killing carp. And under the Environmental Protection and Biodiversity Conservation Act to be able to release it into waterways. So those applications will all be in place and submitted by somewhere around June, July. It'll take about 15 months for the approval process to run its course. During that time, we need to run public consultation nationally. We need to run a risk assessment process to make sure that that all of the risks can be mitigated against. So there's we are only just at the start of this process. I really need to make that point. We need to secure a significant amount of investment to enable us to do this. Right now, this is a theoretical process. It would cost somewhere in the order of $50 million to be able to implement this, to be able to release the virus, clean up the dead fish, undertake public consultation. All of that's really expensive, and so far we haven't got the funds secured for that purpose. We need to undertake monitoring and evaluation of native fish communities, of carp populations, of water quality, of aquatic vegetation, to understand that if we do release this virus, to be able to work out if we've been successful. Everything suggests that it will be an amazing success, but we need data to prove that. And of course, we need to undertake a cleanup. So like I mentioned before, we are talking hundreds of thousands of tonnes, potentially millions of tonnes of carp. So the cleanup will be logistically one of the most challenging things in a pest control context that we've ever undertaken in Australia. It'll be expensive, but there are some wonderful opportunities there too. So rather than doing what they're doing here in America and digging a big hole and putting it in the ground, why don't we consider using this biomass, this resource? We're talking about food security issues in 50 years. Why don't we turn this into, work with some industry champions like Charlie Carp and turn this into fertiliser, increase the yield of our crops, and so the security of our food sources going forward? Why don't we consider turning this into fish meal and feeding it in an aquaculture context, or potentially feeding it to livestock? These are options we need to explore so that we can take what is a good news story, which is fixing the carp issue, and turn it into a better one and turn it into other benefits as well. I've sort of mentioned that we're talking about a large biomass of carp, but so whilst we're taking that large biomass of carp out of the rivers, we need to understand where there are places that are very important to people, where people go fishing, where they go water skiing, where they go swimming. We need to understand where people draw water from for human consumption, and we need to protect those places as a priority. So that's going to be a process of communicating with local governments, with CMAs, local land services, community groups, to identify and to draw on a map the places that are really important to people, and to make sure that as an absolute priority we protect those places. But there are some wonderful opportunities here too. This is something that has captured the Australian community's attention, not just the Australian community, the global community. There was a media release that was put out at the start of January that got shared and adopted and published by 250 media outlets as far afield as the United States and China. We had 6 million tweets generated over a 2-week period about this project. People are very interested, and that's partly because they hate carp and want to see action, and partly because I think there aren't too many examples I can think of where there is an enormous ecological and an environmental issue and there's a solution that potentially we can employ and do it soon. I think that captures people's imagination. And the fact that there's such a high level of interest is great, because it means that there's a very high likelihood that this will transfer to investment and take this from what is currently a theoretical exercise and make it something that we can actually look to do in a couple of years. But we need your help, because, like I say, we're talking about a national initiative. We're talking about an enormous tonnage of fish that need to be taken out. We need to be able to communicate messages with the Australian community about what the evidence showed us, about what the science says about this issue, so that people can make informed decisions about this issue. The cleanup is going to require an amazing level of cooperation and coordination. We're going to need federal government, state government, local land services, CMAs, Rotary clubs, fishing clubs, just members of the community helping out if this is going to be successful. This is going to be Clean Up Australia Day on steroids, with a bit of air freshener, no doubt. But without all of us putting our shoulder to the wheel and helping together, I don't think it'll happen. And of course, we've got opportunities for monitoring. So we've got recreational fishers out in the water every day they're our eyes on the water, so they can help us to collect data on where carp aggregations are occurring, so we know where to release this virus, where large carp kills are occurring after the virus is released, so we can prioritise our cleanup. So there's wonderful opportunities for the community to help us with the monitoring process as well. And look, let me just make the point that when we do this, can we just, if this happens, if we get approval to do this, can we just do it in a way that builds on existing strengths? We've got commercial fishers, as I mentioned, who are absolutely amazing at getting fish out of a river. Why wouldn't they help us to lead the cleanup strategy in that process? We've got recreational fishers who, as I said, are incredibly observant on the water every day in their thousands. Why wouldn't they help us to collect the monitoring information? We've got Indigenous communities that have a cultural connection with their rivers and a strong custodian role for the waterways and the fish. Why wouldn't they play an integral part in this? So I really want to start that discussion as soon as we can about how we all apply the strengths that we have within ourselves to take advantage of this, what I think is an amazing opportunity. So there is potential for us to use this virus for the biological control of carp and to transform our rivers and the health of our fisheries in the process, but I do want to make a point that has already been made tonight, which is even as effective as this virus will be, it is not a silver bullet. If we just do this, if we just release this virus, in a few years, carp populations will start to recover. What this does is it buys us a window of opportunity to do a range of really smart things all at once. We've heard about environmental water being delivered down our rivers, you know, and in this system, we know that it creates amazing outcomes for water birds and for vegetation, but unfortunately it creates a challenge for fish. So, for carp, that is. So why don't we release this virus whilst we're delivering environmental water and maximise the benefit that we get from that water? Why don't we also improve the habitat for native fish and restock those little wetland warriors in places where they become locally extinct so that we can maximise the benefits that we get from this and transform our fisheries and our waterways, not just tomorrow and not just for a couple of years, but indefinitely. So you're going to be interested in timeframes, and I just want to make the point that the monitoring is already underway, so the fish monitoring is already underway, and it will continue for the next couple of years. Like I said, the legislative approval process will take until somewhere around middle of next year at the earliest to be approved. The public consultation starts tonight. So this is really the first opportunity that we've had to get out and talk with the local communities, and I really want to thank you again for turning up in such large numbers, and we want many more meetings and opportunities like this, just like this, and we want to hear what you've got to say, you know, so that we can really understand your thoughts and your concerns and your questions. We're working towards a mid to late 2018 release of this virus, all going well, if we get approval. And let me make that point again. We haven't got approval yet. This is not a fait accompli. It's not a done deal. This is me coming and sharing with you the information, the science, but there is still a chance that this won't go ahead. And of course, we need to explore investment options to make this a reality. And we're doing that right now. And we're getting some really constructive, positive discussions. We've still got a long way to go. I want to leave you with just this one last point about the potential benefits. So this is a place, this is Lake Wingra in Madison, Wisconsin. If you can see this here, this lake, Lake Wingra, was a lake that the community had stopped using because it had regular algal blooms. It was a manky sort of environment. You wouldn't want to swim in there. It was all dirty water. And the locals decided that they wanted to fix this. They wanted to restore the health of the lake. And so what they did is they found out that it was carp that was causing the turbidity issue, that was causing the algal blooms. So they created this big fence, and they fished out all the carp and removed them. And of course what you can see there is a dramatic change in clarity. So outside of the pen, really turbid, inside the pen, quite clear. That was all the community needed to go, right, this is a goer. So what they did, fortunately this lake freezes over in winter. So once the lake froze over, they dug a hole immediately above the very deepest part of the lake, and they seined all the carp out. They removed 90% of the carp from this lake by doing that. And essentially what happened was the water quality improved, and the people started to come back to fish and to swim. And we can see that right through the Murray-Darling Basin, right through the rivers in your backyard, but we have to take action on carp. Look, I want to thank you for being so patient and coming out tonight. If you've got any questions, I'd really love to hear from you. Thank you.